So here 8 OR gates are present, OR-A to OR-7, OR-0, OR-0 to OR-7. So 8 OR gates. Also each OR gate we have 8 bits input. Each OR gate 8 bits input. So I have tried some coding for that. OR gate, I have tried some coding for that. So here it is 1 OR gate, 8 bits input, 1 OR gate, 8 bits input and 1 output, which means OR0 alone I am taking. OR0 alone I am taking. And then when I execute this, I am getting waveform something like this. So you can see here when all inputs are zeros, output is 0. All inputs are zeros, output is 0. Here this W7 is high. Okay, at least one input is high, output will be high. So here also at least one output is high. Here 2 bits are high, so output is high. And this continues up to here, it is high. If you see here 8H00 means all the 8 bits, all the 8 input bits are zeros. Only during that time we will get output 0. Again here 1 bit is high, so output will be 1. Okay, OR gate means when all the inputs are zeros, output is 0 here. When all the inputs are zeros, output is 0 here. Okay, so that is about one single OR gate, which is OR0. OR0 alone I have executed. Then a combination of OR0 to OR7. OR0 to OR7. You can see here each OR gate should have 8 bits input. 8 bits input, like that 8 OR gates together. Like that 8 OR gates together we have to see. And that I tried. You can see here A, B, C, D, E, F, G, H. These are the 8 OR gates. OR0, OR1, OR2, like that up to OR7. Okay. So everywhere I have set some input. Okay. So all these 8 OR gates I have given inputs. Okay. These are 8 OR gates. OR0 to OR7 in the base paper. OR0 to OR7. Okay. I have designed. So totally 64 bits input should be given. So here 8 bits, next one 8 bits, next one 8 bits, like that 64 bits input should be given. Okay, so we have 64 bits here, 0 to 7, 0 to 7, like that totally 64 bits are available. And Y is the output. You can see nothing is there presently in the output. Y is the output, nothing is available in the output. And when I tried for the output, 8-bit OR gates, 8-bit OR gates. So this is the output. You can see this is the output. Okay. So when first bit Y7, Y of 7. Okay, Y of 7 will come 0 when the A will be all zeros. Okay. A all zeros means you have to enlarge here, and here at least one bit is high. Okay, at this point output will be high. And then when all are zeros, that we have to identify where all are zeros, that only here I think all are zeros. Only at this point we should get the output as 0. Okay, something like that. And you have to check which is LSB, which is MSB. Okay, which is LSB, which is MSB. Here it is 0 to 200, 0 to 200 time. But here, yes, initially all are zeros, 0 to 50. 0 to 50 all are zeros. At that time output can be obtained 0. 0 to 50, like that. Okay, so you can see up to here output is 0. Okay. Then everywhere output is high. Y of 7 is high, because in A 8 bits, nowhere we are having all the 8 bits zeros. Okay, like that I have tried. Y of 6 is the output for B. Y of 5 is the output for C. Y of 4 is the output for D, like that. Here 8 OR gates are there. OR0, OR1, Okay, OR2, OR3, like that, OR7. So OR7 means the last one OR gate. This H is the OR gate. And the output bit is Y of 0. Output bit is Y of 0. Like that, I have got some output for the OR gate. So now what is completed? What is completed here? This OR gate is completed. This OR gate I have completed. So next priority encoder, 8x3 priority encoder. Last time itself I have, last semester itself we have done 8x3 priority encoder. So for that I didn't try waveform here. But the previous, or I tried and deleted, something like that. Okay. But I have the waveform. Priority encoder somewhere. I didn't activate any waveform here, but that output is coming. That last time itself we have 8x3 priority encoder output. Okay. So that, let me see. This is 2x1 mux. This is also 2x1 mux. So priority encoder, I didn't activate the waveform. Okay, but I have the file. Priority encoder file is there. This P priority encoder file is there. Okay. Last time itself we got the output waveform. Okay. So it is working. Just I have taken it for the structural model. I have taken it for the structural model. Okay. This is the file. Waveform I didn't activate. It will also work. I will simulate and give the priority encoder. It is working. Next I am going to 8x1 mux. 8x1 mux. So it should be designed in this fashion. It should be designed in this fashion. Everywhere 2x1 mux is there. But you can see here 8 inputs. This 8x1 mux is 8 inputs are there and 1 output. Okay. So here also 8 inputs are there and 1 output. Okay. And each of this is nothing but 8 bits. Each of this is again 8 bits. This is 8-bit input, 8-bit input, 8-bit input, 8-bit input, like that 64 bits input will be there. For the 8x1 multiplexer, 64 bits input is given. Okay, it is dividing as 8-bit like that 8 times. And here I have taken 2x1 mux first. I have taken 2x1 mux first. And for that, I have just tried the waveform. This is the waveform for 2x1 multiplexer. Okay, 2x1 multiplexer, what you have in the base paper, 2 inputs are there. Okay, that is OR gate what I have opened. This is OR gate I have opened. OR11 I have opened. 2x1 mux. This is the waveform for 2x1 mux. So we have 2 inputs. 2x1 mux, we have 2 inputs. Both are 8 bits, 8 bits. And 1 selection line should be there. Okay, 2 inputs, 8 bits, 8 bits. A and B are the 2 inputs. You can see 8 bits A and then 8 bits B. Okay. And then X is the output. X is the output. Nothing is there presently. After simulation, we will get 1 bit selection line also available here. 1 bit selection line also available here. And then the waveform, 2x1 multiplexer waveform, 8 bit 2x1 multiplexer waveform. You can see A is given. Okay. 8H10 means 8 bits. 10 should be in 8 bits. 8 bits hexadecimal. 8H means 8 bits hexadecimal 10. 8 bits hexadecimal 52. 52 means 5 should be written as 0101. 2 should be written as 0010. Okay. Then here 8 bits hexadecimal C0. Again you have tried C and 0 4 bits. Like that A and B are the inputs. Selection line is there. When selection line is 0, A should come at the output. Okay, output is X here. You can see A and X are same. A and X are same when selection line is 0. When selection line is 1, okay, output should be B. So B and output are same. Until selection line is 1, B and output are same. Again selection line is 0 here. Selection line 0 here. Again A should come at the output. Okay, A and output X are same. Okay, I have just expanded this X. So we are able to see all the 8 bits in the X. Otherwise, you can check the X here itself. 8H52 and A also 8H52. And here 8HC0, 8HC0. And here selection line is becoming 1. Selection line 1 means B should come at the output. 8HC9, 8HCB. Okay. Then again 0. 0 means A should come at the output. So 8H34, I think 8HA5. Okay, this is the output of 2 by 1 multiplexer. What I have shown you is only one 2 by 1 multiplexer. I have shown the output. Now this entire structural model, okay, it is present inside the 8 by 1 multiplexer. So 8 by 1 will have 64 bits input, 3 bits selection line, and a simple 8 bits output. Okay, simple 8 bits output. So internal design is like this. And when I designed that 8 by 1, I think that also I deleted here, but I executed and got the waveform. Okay, coding also I have it. 8-bit structural model. This is 2 by 1. 8-bit structural model, this one, 2 by 1 mux, 8-bit 2 by 1 mux. I got the output waveform for this. This is 2 by 1 coding only, 2 by 1. So from yesterday, I was just trying your review, but I'm breaking my head. Venkataganesh is busy. Even for Gmeet, he cannot come. Okay. So 8 by 1 mux here. 8 by 1 mux. Yes, some things I have deleted. Okay, somewhere it went wrong. Some things I have deleted, but I got output for that also. I think I have saved it. I will just search and give you that 8-bit 8 by 1 mux. Okay, 8 by 1 mux output, something I have written here. This is not 8 by 1 mux. This is 2 by 1 mux only. $64 bits because I checked output came. Okay, I checked output came. I will try it once again. This is also completed. Okay, this is also completed. Now the thing is, I'm trying for already 8 by 3 priority encoder is working. I told you this 8 by 3 priority encoder also working. Okay, so I have to combine all this. I have to combine all this and get some 6 bits output. Okay, 6 bits output, 64 bits input. 64 bits input and 6 bits output. So you can see here 64 bits input. Okay, 64 bits input, overall input, and 6 bits output. Okay, 6 bits output. And this priority encoder enable means here 1 bit enable will come. Enable will come 8 by 3. 8 by 3 means here enable bit is also there. That's why I have put that. So otherwise 64 bits input and 6 bits output. I have activated the truth table. And coding also I am trying that. Morning before lunch I got error in that. Before lunch I got some error here. You can see here 63, line number 63, 61. 2 errors I am getting in this file when I am merging all this coding together to form the structural model. Okay, so what I have shown you is individual blocks in the base paper for figure 1. Individual blocks for the base paper figure 1.